Hello and welcome to the class on randomized block design. In this design, initially the whole experimental material is divided into several homogeneous blocks. The homogeneous blocks are further divided into a number of experimental units. These experimental units are equal in all respect, and the treatments are applied randomly to the experimental units. In RBD, the experimental material is initially divided into several homogeneous blocks. Let us try to understand this concept with the help of one example of having three breeds of cattle as our experimental material. These breeds makes the experimental material heterogeneous. Now, to form a homogeneous group, we should allocate one breed to one group. These homogeneous groups are known as blocks. The blocks are further divided into a number of experimental units, and the treatment is allotted randomly to each of these experimental units. So in RBD, the total experimental material is initially divided into blocks. The blocks are further divided into several experimental units, and the treatments are applied randomly to the experimental units. RBD is nothing but a collection of CRD, each run within one of the blocks of the total experiment. Here, the term block is an extension of the term pair, and hence RBD ANOVA is an extension of paired t-test. In animal science experiments, we can block the experimental material on several criteria such as location, age, breed, body weight, temperature, etc. RBD follows all the three basic principles of a good design of experiment, such as randomization, replication, as well as local control. Let us try to understand the concept of RBD with the help of one example of testing the effect of four types of feeds on three breeds of cattle. Let us randomly allocate the experimental material to our treatments. A respective feed will be fed for a specific duration to the cattle in each experimental unit, and the body weight of all the cattle will be measured at the end of the experiment. This particular experiment can be plotted in a tabular form. This is a tabular representation of randomized block design. In a randomized block design, the number of treatments multiplied by number of blocks will give us total number of experimental units. Each experimental unit will have many replications within itself. That is, each cell will contain many observations. The equation of randomized block design will be jth observation of ith treatment is equal to overall mean plus the effect of treatment factor plus the effect of block factor plus the differences between the observations. Important points to be remembered in RBD are that block what you can and randomize what you cannot. The number of experimental units in each block should be equal to the number of treatments. Variations within the block should be as small as possible, whereas the variations between the blocks should be as great as possible. There should be randomization of treatments within the block. RBD is suitable when the material is heterogeneous with respect to one factor. RBD can be used safely for up to 20 treatments. And if some of the observations are missing, we can apply the missing plot technique. This slide represents the differentiating points between a completely randomized design and a randomized block design. Thank you.